Hi class, this is Dr. Musk, and we are going to discuss Chapter 16, which contains the functional groups aldehyde and ketone. All right, so remember that aldehydes and ketones both contain that functional group, carbon double bound to oxygen. We call that a carbonyl group. So the compounds that we're going to discuss in Chapter 16 are ones that have only hydrogens or carbon atoms bound to the carbonyl group. All right, so an aldehyde has to have at least one hydrogen bound to the carbonyl group, and a ketone has two alkyl groups, so two carbon-based groups bound to the carbonyl group. There are also some other kinds of carbonyl-containing compounds that we'll discuss in later chapters, including carboxylic acids, esters, and amides. All right, so it turns out that esters and amides are considered to be derivatives of carboxylic acids. And what that means is that most of the time, when you create an ester or an amide, the thing that you start with to turn it into that ester or amide is a carboxylic acid. But now let's get back to aldehydes and ketones, which are the real stars of Chapter 16. So first of all, you know that whenever we have a carbonyl, that is going to have trigonal planar geometry. All right, 3 electron groups, that double bond being one of them, and then the 2 single bonds being the other 2. That's going to give us a bond angle of 120 degrees, and the carbon-oxygen bond is polar. All right, that generally means that carbonyl-containing compounds are polar compounds. So let's take a look at a couple of examples of an aldehyde and a ketone. So a 2-carbon aldehyde could be called ethaldehyde or ethanal, but acetaldehyde is another common name for the same thing. So you can see that when we abbreviate that in condensed structures, CHO is our abbreviation that is the universal one for aldehyde. I don't particularly like the condensed form that they've given us here for acetone, so I would prefer something like this instead. And that way you can actually see the carbon-oxygen double bond, but either way you should be able to figure out, based on the number of things bound to each one of those carbons, that that oxygen has to be double bound to that central carbon of acetone. So how do we name aldehydes? We find our longest chain containing the aldehyde functional group. Remember that because the aldehyde functional group can only be at an end, the end is essentially the beginning in this case. In other words, wherever the aldehyde functional group is carbon number 1. All right? We don't need to give a locant to the aldehyde functional group because it's always going to be at carbon number 1. And the suffix that we use for aldehyde-containing compounds is al. So let's talk about the names for each one of these aldehydes, all right? And I'm not going to use the PowerPoint slides. We'll just talk through them together ourselves. So if we count our longest carbon chain, 1, 2, 3, 4 carbons long, it looks like we have methyl groups at carbons 2 and 3. So we would call this 2, 3 dimethyl. Remember, we have to give locants to each one of those methyl substituent groups. And then since it's a 4-carbon longest chain, methyl ethyl propyl butyl, this would be dimethyl butanal. All right, 2,3 dimethyl butanal. Now, what about our longest carbon chain in B? If we counted straight across, that would be wrong, and the reason why is because even though it's a longer carbon chain, it does not contain the aldehyde functional group. So our longest chain containing the aldehyde functional group is 5 carbons long. We have an ethyl group at carbon number 2, so this would be 2-ethyl pentanal. Remember, we don't have to give a locant to the aldehyde because it's going to be at carbon number 1. So there are common names for a number of very simple aldehydes. You don't need to use either one of these if you don't want to. All right, so formaldehyde and acetaldehyde are common names, but we could name that first one methanal and the second one ethanal, the systematic name. Those are just as common. Now, this is a common name that you really do want to remember. All right, so very similarly to when we had, for example, a methyl group attached to a benzene ring, and we just call that thing toluene as a common name, we're going to use this name, benzaldehyde, for whenever we have a benzene ring with an aldehyde attached to it. So what about naming ketones? All right, it's very similar. We're going to find the longest chain that contains the ketone functional group. We use the suffix -one to talk about ketones, and we're numbering to get to our ketone as soon as possible. All right, and then we just apply the same rules that we've applied other places. So it looks like we have a 5-carbon long main chain here. All right, the ketone is at carbon number 2. We have a methyl group at carbon number 3. So this would be 3-methyl 2-pentanone. Remember that 2 is the locant for the ketone. All right, now we don't have to give a locant for that ketone that is in the ring. We're assuming that is at carbon number 1. So how would we name the one in B? It looks like we have an ethyl group at carbon number 3 of the ring and a methyl group at carbon number 4 of the ring. So ethyl comes before methyl alphabetically. So this would be 3-ethyl 4-methyl cyclohexanone. Sweet. So, in terms of common names for ketones, don't worry about them too much, all right? We can do a similar thing with ketones that we do with ethers by just naming the two alkyl groups attached to very simple ketones. There is one common name for a ketone that I do want you to remember, and it's one where we have a carbonyl group and then a methyl group attached to a benzene ring. So this entire thing has the name acetophenone. All right, so acetophenone can be used as a base name for that entire structure, the same way that we would use phenol or toluene or benzaldehyde like you just learned about. So, for example, if we had something that looked like this, so there's our acetophenone, and then why don't we add a bromine and a chlorine to it. So take just a second and see if you can name that. Now, when we count around from the carbon with the carbonyl group attached, we could get to our bromine at carbon 3, or we could get to our chlorine at carbon 3. So bromine comes before chlorine alphabetically, which is why we should count in this direction. And because of that, I would call this 3-bromo 5-chloro acetophenone. So I just totally destroyed my, destroyed my chlorine in there. So yeah, I would call that thing 3-bromo 5-chloro acetophenone. So acetophenone, and then also benzaldehyde. Make sure you remember those as benzene derivatives that we can use in our naming, all right? Because it's hard to name them apart from that convention. And I think in terms of, oh, look, we do have acetophenone here. So that was in the PowerPoint slides. I can't remember if, I didn't remember if I remembered to include it. Don't worry about memorizing benzophenone, because other than benzophenone itself, we're not going to name anything with more than just 2 benzene rings attached to that carbonyl. But do remember acetophenone, and acetone is such a common name that it's probably good to remember that one as well. All right, so the bond line version of acetone is even easier to draw. The reason why we remember benzaldehyde and acetophenone is because it's kind of hard to remember how to name derivatives of those, ones with other substituent groups, unless you remember those names themselves. All right, so we've done just a little bit with structure and naming for aldehydes and ketones, and hopefully you've enjoyed it. Thank you, guys.